So to implement the search, sequential search, couple of versions of it. I guess I could do. I can base it on my index, right? So I can say int index start from 0, then have a for loop which loops from the starting index position to index which is less than my list size, and on each iteration increment index. So here I can say sequential search for Joe, right? So let's do the same type of search, but instead of doing binary search, let's do our own version of sequential search. So we start from index 0 and execute our search, assuming that the list is not sorted. So we have to say if um, if let me try something here. Joe. Compared to my list get value at index how many parentheses I have here? 1, 2. I need this extra one. Okay. So um, 0 equals compared to get index. Then we just say break, or we can print this same thing. At position index, my list get index. And we break because this is it. Otherwise, we continue the search. So look at this. By the way, let's execute this and make sure that it's so. Both work. Of course, this one is much more efficient because it's doing the binary search and not sequential search. But my version of sequential search also works, assuming this is an option that I have to take in case if the collection is unsorted. The sequential search is my only option then to do my search for an element. So, but look at this curious syntax. I'm using Joe as a temporary, string, if you will, and so this is a string object. So quote Joe on close quote is actually an object in Java, right? And because it's an object, I can say dot compare to. It's one of the syntaxes that can be used, but I could otherwise say string search for equals Joe right here, and then perhaps this would be more something that you're used to seeing, but either syntax will work. Most likely this will be inside some method, and maybe to search for argument is passed into the method as a parameter. Okay, so this works. Yet another version of the search could be this, right? Search for Joe, version 2. So in this version, we can say for. Remember that we can use this enhanced loop structure for string str in my list. Basically do the same thing. If search for compared to the string, right? If I'm searching for Joe, and if I say compared to the string and it returns 0, it means that we have an exact match. And then again, I will print at position, at unknown position. Now I don't know what the position is. I'm just, this loop only gives me access to the string. This loop doesn't provide any notion of the actual index or any position inside my list. So at unknown position, I am finding this string, which I was supposed to look for. So that's how my code will change in this situation, right? So make sure that you're comfortable with all these variances of code that I'm trying to use. Let's run it. We should have three versions of it, and this last one really doesn't give you a chance to where's my output, to know what position is. At unknown position, but Joe was found there. Similarly, you can view the searches as not really finding one unique element, but perhaps there may be multiple entries for the same element in the collection. In that case, you could count. You could count occurrences of this thing, right? So search quickly could become a different algorithm, which requires sequential processing. And I think in the collection class, again, if we jump to the beginning, you can search for count. No count. What terminology is used here? I just saw something. Search, check, copy, empty, fill. Frequency. Frequency returns the number of elements in the specified collection equal to the specified object, right? So we can check the frequency. So instead of count, collections utility class is using the frequency. So we can do this. Int count equals collections frequency of my list, and what I'm looking for is Joe, right? Or actually I can specify search for what I'm searching for to make it more generic. So this is my statement, and then I can print this. I can say that search for, which is string, right here, search for is found count times. Okay, so let's save this and let's run it. So Joe is found 1 times. It should be saying 1 time.